Hello,
Hello,
biology
biology
students.
students. Today's lesson is lesson 3, evidence of evolution, and our question to think about is why do humans have tailbone? Why is that? So I'm going to go through 6 pieces of evidence of evolution, and your task is going to be to write it down notes as I'm speaking. So you should pause the video so you have time to copy everything down, because I'm just going to go through all the 6 pieces at a faster pace. So on Schoology, there is a Word document that looks like this. 1, 2, 3 pieces of evidence, 4, 5, 6. So you can either upload this to Notability and write it on your iPad. You can copy this down on a piece of paper and then take a picture of it to submit it when you're done. Whatever you choose to do, you're going to jot down notes on these 6 pieces of evidence. You're going to write down 2 things: the description, and on the notes I put a D next to that so you can see it really clearly, and then the significance, and I put an S next to those notes. Significance is a fancy word for why is it important. In other words, why does this provide evidence that evolution happened and is happening today? So the 6 pieces of evidence that you're going to write about are fossils, geography. I know many of you are in geography class right now, and geography and science is slightly different. Embryology, that ology should remind you of study of homologous structures and analogous structures. Homo means same or similar. For this, it's going to be a little different. For number 4, I've split it up. We're not going to write down the significance for analogous, just for homologous, but we'll write a definition or description for both. 5 is vestigial structures, and then the last is one that we've studied before: DNA and protein sequences. Right. At this point, you should have notes set up somehow on a piece of paper or 2 screens up on your iPad so you can write things down as we go. And like I said, pause so that you have time to write, because I'm just going to whip through these 6 pieces of evidence. So here's this intro slide. You can see all these are fossils, which is our first piece of evidence. This is a picture that an artist made of what the Earth looked like before life was there. Lots of volcanoes and storms, and it was not a good place for life yet. The Earth is about 4.6 billion years old, and life has been there for most of that time. So it has been changing for a long time. We started as just one single-celled organism, and today we are what we are. This slide right here is kind of the whole point, the significance. You're going to be writing something like this down many times. That all organisms have a common ancestor. Way back in time, millions of years ago, we all started from something that was the same, and then we branched off into the different life forms that we are today. So here is description, and here is significance for fossils. What fossils are is something that used to live a long time ago that we have that remains today. Sometimes it's an imprint, so just like a shape of something into a rock, like this leaf here, and this fish here, and then sometimes it's the bones have actually turned into a rock. Kind of rock that it's in, if you remember from 8th grade, is sedimentary. That's the kind of rock that's around St. Paul, so we have lots of fossils in St. Paul. The significance is this, that the oldest forms are on the blank here should say bottom. The youngest forms are on the top. So literally we can dig through time back to where older things lived. And if somehow the rock layers have shifted, you can actually age the rock to see how old it is, so that we can confirm that it was a 500 million year old fossil, for example. Fossils are a really easy, clear piece of evidence. This is the kind of rock around St. Paul. It should be familiar. So we do have a lot of fossils. Not necessarily dinosaur fossils, but other kinds of fossils that used to live here. The second piece of evidence is geography. And really, it's just an easy description right here, D. It shows where species live. Here is a picture of two birds that are related, but they live in different environments, so they have different features. This one has a thick beak for maybe eating a nut or seed. This has a thinner beak for eating something different, like an insect. And because they have different environments, they have evolved to look different, so that their traits fit their environment. So they look like each other, they're related, but they live in different areas. That's the geography part. Where do they live? So again, just showing that, I think I have the slide here to show that these islands right here off the coast of South America are really key to studying evolution. We'll talk about this later on, but a lot of these islands, they're called the Galapagos. You can't see that, it's so tiny. The scientist Charles Darwin discovered that depending on the environment, the organisms evolved different traits. So here's the significance. Adaptations fit their environment. This iguana lives on a dark rock and it has dark skin. This iguana lives in trees, so it is green colored. Both can blend in or camouflage with their environment. These are related creatures that live on one island, but they live in different parts of the island of Australia, so they have formed different traits. Koala in the trees, kangaroos on the land. The third piece of evidence is super interesting, embryology. We were embryos before we were born. So this is the description. We study things life before it is actually born. It shows evidence that we came from a common ancestor. This is a larva is like a baby before it becomes an adult. And then this is all sorts of different organisms in their different life phases. This is a fish, salamander, tortoise, a chick or chicken, hog or a pig, calf, cow, rabbit, and us, human. Organisms in their different life phases. This is a fish, salamander, tortoise, a chick or chicken, hog or a pig, calf, cow, rabbit, and us, human. Take a second and notice. What do you notice about life phase 1? If I gave you a quiz, could you tell the difference between a hog and a calf? No, you could not. This gives us evidence as to that we all came from something, a common ancestor. We all came from something and then branched off into looking different as we do today. Also, notice that we have a tail, which is kind of part of the answer to why we have a tail bone. Before we're born as an embryo, we have a little tail before it drops off, and we have our two arms and two legs. The fourth piece of evidence, homologous structure. Again, that homo means same or similar. Same structure, same shape, but different function, different job. So human hand, a mole, which is kind of like a little animal that digs in the ground, and a bat. We have three different functions for our hands, feet, and wings. But we have the same bones. A bat has 5 bones in its wings. A mole has 5 bones in its little hand that digs. And we have 5 fingers as well. So same structure, but obviously really different use or function. And this is significant because it says that we all came from a common ancestor and then branched off into our 3 different life forms. Oops. Another picture of that, these wrist bones and arm bones in a human and a cat, a whale and a bat. So bat flies, different function, a whale swims, different function, a cat walks on its hands, and then we use our hands for multiple uses. So homologous structure, same bones, very different function. Another picture, just because I love these things. So a bird, these are 3 animals that use their bones to fly, 2 that swim, run, and then grasp or hold things. We have all the same structure, same bones, but very different function. That's contrasted with analogous structures, similar function, but not similar in structure. So a penguin uses its flippers to swim. A fish uses its fins to swim, but they have really different structures, right? This has bones in it. This has no bones. A bird has bones in its wing, and so does a dragonfly. Also has wings, but no bones. So they have the same function, but really different ancestors. Okay, so I just moved this down so you can see that word origin. Not similar in origins. They did not come from a common ancestor, but they have a similar use. Flying, swimming. Number 5, one of my favorites, vestigial structures. So the description is here. They're evidence of your past ancestor, but the structure has no real function today. So ostriches have wings. Why? They don't fly, but it shows that maybe they have an ancestor that did fly. So they evolved from something that was a flying bird. Whales have leg bones. They have a femur. It's so strange because they do not have legs, but it shows that their ancestor, this is just an artist's drawing, but this is a real picture of a fossil, that their ancestor did have back legs, and then slowly over time it changed, and so that the leg bones got smaller and smaller until they are just so teeny tiny that they're in the whale's body, but they're of no use. Here's the significance that organisms, they change. Life changes over time. The leg bones never disappeared completely because they're not hurting the whale. They're just not used for anything. But it gives us evidence or proof that the whale didn't always look this way. We have other examples here. Pigs have extra toes. Snakes also have hip and leg bones, very tiny bones in their bodies. We have an appendix that shows that we maybe had a different diet. Some of you might have heard of someone that had their appendix out. We don't need this thing, but it is evidence that maybe our diet, we evolved from a different kind of human being that ate different food. The last one is, I think, maybe the simplest one to understand, because we've learned about it before. We can now, today, we can compare DNA and protein sequences. So here's a hippo, here's a humpback whale, the A's, the T's, the C's, and G's, and you can see they're really closely related, so they have a common ancestor. Here's the significance that you can write down. A human, we're comparing a human to all of these different kinds of animals. A gorilla, a monkey, a mouse, a chicken, a frog, and a lamprey. You can see that we have the most in common with the gorilla because we only have one different amino acid in our blood. Whereas a lamprey, which is like a snake-like thing that lives in the water, we have a lot of different amino acids. We're obviously not very closely related to that, or a frog or a chicken. We have more in common with these animals. And we can prove that through DNA and through proteins. Again, 98% of our DNA matches a chimpanzee's versus this little simple monkey we have less in common with. So we can now look at these things through DNA and protein sequences to prove evolution, that life changes